Okay, my little engineers, today we are going to review the 2-bit adder. And here's our objective for the day. We want to be able to identify inputs and outputs. Hopefully we remember what gates or chips correspond to addition, multiplication, and the not. Um, and we're also going to get started maybe building our Tinkercad circuits and building our circuitverse sketches for the 2-bit adder. And one of the big things I want you to understand is that there are actually multiple correct solutions to this problem. And it's going to be up to you which solution that you actually like the best. So, just a real quick reminder, we are building a calculator. But the calculator that we are building is for binary numbers. So it's really going to help if you have a strong base in your binary numbers and that you can remember all of your binary numbers as well, at least up to 3 for this case. So we have to deal with these 4 math problems. So 0 plus 0, pretty simple. It's going to be 0. 0 plus 1, also simple. Going to be 1. 1 plus 0, that's right, it's 1. And 1 plus 1 is going to be 2. No, there's no 2. Get out of here, 2. We know that the real answer is going to be 1, 0 because we are working in binary. So now that we have these 4 math problems set up, we want to be able to load all that information into a truth table. And so again, which of these things are we able to control? Which of them are inputs and which of them are outputs? Hopefully you recognize that the numbers that we put in are the inputs. So the 2 numbers that we get to choose, and then the output is the computer adding those 2 things together. So we'll call this guy A, B, and for your 2 outputs, you could call them X and Y if you wanted to. I'm going to call that guy the carry, more specifically the carry out, because it's an output. I'm going to call that guy the sum. Now, let's load these into a truth table, and it should look something like this. We know our inputs are always going to look like that for a truth table. But remember, for 0 plus 0, the output is going to be 0, 0. For 0 plus 1, 0, 1. For 1 plus 0, it will still be 0, 1. And for 1 plus 1, the result is 1, 0. Now, you could use your project notebook and just look at these 2 sets of outputs, and you should be able to figure out which gates to use. And that's going to be kind of my big hint to you. But if you are struggling with that, or if you just want more practice with K-maps, we can absolutely do that. Here is the carry out loaded into a K-map. And you can see that there's only 1, 1 to be circled. And so there it is. And we recognize for that circle that A is 1 and B is also 1. So our result is AB. For our sum, it's going to be a little bit different. And when you look at this at first, you might be a little frustrated because we have no way of combining those 2 ones. So in fact, we need to make a circle right there, and we also need to make a separate circle right there. We can't combine them at all. Again, my big hint to you is look at the truth table and go back to your project notebook and see if you can find a truth table that lines up with that 0, 1, 1, 0 for the output. But again, when we look at our yellow circle, we see that A is equal to 1 and B is equal to 0. So that will be A, not B. Our red circle, where we have A is equal to 0 and B is equal to 1, that will be not A, B. So at this point, we have our 2 equations. We have an equation for the carryout and we have an equation for the sum. go ahead and try and build that circuit in Circuitverse after you have updated your project notebook. Good luck!